record, and then we'll get started. One thing that this section has is actually has like several word problems, but they're mostly to do with like geometry. So volume and area. And so we're going to start there. First off, factoring is a really important tool when discussing word problems that have polynomials and quadratics. And as I've been mentioning kind of along the way here, factoring ends up being an extremely important tool when you get to physics, has a ton of factoring in it. And actually grade 12 chemistry has a lot of factoring in it as well. And so this is not only an important tool for your math courses, you will definitely be doing all of this in grade 11 and 12 math if you take it. If you take calculus, it will be there as well. It's an important tool in the sciences as well. So it's a really vital tool here. So let's just do kind of a basic word problem here. So the trinomial represents the volume of a rectangular prism. Determine the dimensions of the rectangular prism. So this one's a little bit different than other questions that we've seen. The first thing that I'm going to do, actually I have to switch over to here, there we go. Okay, the first thing that I'm going to do, does anyone remember the volume of a rectangular prism?
The area of the base times the height.
Okay, yeah. Base times height. That's for like any prism, right?
Yeah.
If you know the area of the base, then you multiply by the height. And if we're dealing with a rectangular prism, then the area of the base is just length times width times height. Mm-hmm. So the volume is equal to length times width times height. And so, but this thing here does not look at all like length times width times height, right?
No, it does not.
It definitely does not. So our goal is to write out this polynomial as a series of 3 brackets, okay? Or a series of something multiplied by something multiplied by something. And that will represent our length, our width, and our height, okay? There's also several questions in the homework. I think there's an area question. Let me just pop in here and see really quickly. 250. Scroll back up just slightly here. Yeah, the area of a circle is given by a certain relation, determine an expression for the radius, stuff like that. The volume of a rectangular prism is given.
Mr. Hoppin.
Yeah.
Sorry to interrupt, but I can't see your screen, so I'm gonna leave and rejoin. It happened before, so I don't really know why it's doing it.
Okay, yeah, no worries. Can everyone else see what I'm writing?
Yeah.
Okay, cool.
Yeah, probably. I don't know. It's happened before. I'll just come back in.
Yep, sounds good. Okay. Yeah, so our goal right now is to turn this into like volume equals something times something times something. And the way that we're going to do this is by factoring, okay?
Beautiful.
So we won't be able to figure out what the length, the width, and the height are, like number-wise, but we will be able to find an expression for the length, an expression for the width, an expression for the height. So that's kind of our goal with this, all right? But let's walk through, I mean, we've been factoring quite a lot. And so let's more focus not on like the methods behind factoring, but why we factor a certain way first, right? And we're going to be discussing that more on the breakdown of exactly how we go through the factoring process here, okay? But let's kind of walk through it here. So the one thing, or I guess the first thing I notice here is that each term is divisible by x. And so because each term is divisible by x, I can common factor first, right? Common factor. And that's always the first step that you take when you're factoring something, okay? And so let's do that here. So I have 8x to the power of 3 minus 6x squared minus 5x. And we can take out an x, okay? And when we do that, all the powers of our polynomial decrease by 1. So we get 8x squared minus 6x minus 5, okay? So common factoring is always the very, very first step that you take whenever you're trying to factor something. Okay. Now, from here, the check that we want to do is what the value of our leading coefficient is, right? So check leading coefficient. This is essentially the flowchart kind of diagram or methods that I was asking you to do on your quiz on Friday, but we check leading coefficient. So if the leading coefficient is equal to 1, then we use sum and product. And if the leading coefficient is not equal to 1, then we use, or we try to use decomposition. Okay. In this case, I'm doing this step in particular because I recognize that I have a trinomial inside the brackets here. Now, there are also other things that I should be checking for, right? On Thursday of last week, we checked, or we learned how to factor difference of squares and perfect square trinomials. We should also be checking for that as well. However, looking at this, I realize, oh, well, 5 is not a perfect square, right? And neither is 8. So I'm not dealing with a perfect square trinomial. I'm not dealing with the difference of squares. So I kind of just skipped those two, okay? So in this case, my leading coefficient is 8, so it's not equal to 1. So I'm using decomposition here. And so for this example, I need to factor 8x squared minus 6x minus 5. So I have to find two numbers that multiply to give me 8 times negative 5, and two numbers that add to give me negative 6. So this will be multiplied to negative 40, add to negative 6. That is going to be negative 10 and positive 4. I am then going to split up my middle term, right? So 8x squared minus 10x plus 4x minus 5. And then I'm going to factor by grouping, right? So I group these two, or sorry, yeah, I group the first two terms together. I group the last two terms together, and then I factor each one independently, okay? So 8x squared and 10x, I can factor out a 2x out of that. And so I will be left with 4x minus 5. And then plus, and now, again, whenever I'm doing decomposition, I always want to have the same bracket kind of repeated twice, right? In this case, that bracket is going to be 4x minus 5. So for the second grouping there, there's not really anything to factor out, right? So in this case, I'm just going to write plus 1 just as kind of like a placeholder to remind me, and then 4x minus 5. And then I factor out the common bracket, so 4x minus 5, and whatever is left over after I do that, so 2x plus 1. And then that's it. I factored this thing. But I have to be a little bit careful now. So going all the way back up to the top here, the very first step I did was I common factored out that x, right? Now that is still part of my expression. So after I'm done factoring the quadratic, I have to make sure to kind of put everything together, okay? So what I'm gonna do is I'm going to drag this all the way down here. So my full factored polynomial will be equal to x times 4x minus 5 times 2x plus 1. And that is my final answer here, okay?
So that's like your length times width times height there.
Exactly, yeah. But we don't necessarily know which one is which, right? We don't know which one represents the length, which one represents the width, which one represents the height. But in this particular example, it kind of doesn't matter, right? Actually, this question is really similar to one that my my grade 12 advanced function students were doing. They also had actually, I can pull it up just to show you guys. They also had a factoring style question on their last test. Let me see here. Let's see, polynomial functions, test 2. Let's see what we got. Yeah, so they had to do a similar box question, actually. So if I go down here, but this time they had to actually set up their own box. But essentially they had a box and they were given a volume and they had to figure out the length and the width and the height of this new box. So this is a common style of question. Usually with like application problems like this, they always go back to geometry, right? Because geometry is kind of really familiar to us. You guys have built up your geometry knowledge since like middle of elementary school, right? So these types of questions just kind of come back again and again. Actually, this is a factoring question as well. So I mentioned it earlier, but factoring just kind of sticks with you, right? Throughout all of the rest of your math years, you will be factoring. So get good at it now, right? That's kind of the moral of the story there. Okay, back to our stuff here. So yeah, just I think we mentioned this, but whoops, let's expand this out here. So we don't know what the length and the width and the height are, but we can just say length is equal to x, width is equal to 4x minus 5, and the height is equal to 2x plus 1. But we note that the order here doesn't matter. Order doesn't matter. Okay. So that is an example of a volume question that we can answer using factoring, which is really cool. Does anyone have any questions on that? Okay, cool. Okay, just a couple more questions. Today is actually kind of a shorter lesson. It's mostly like a culmination lesson. Really no new material here at all, but Owen, are you fixed? Does this work now?
Yeah, no, I'm able. I was watching this since I joined back.
Okay, that's good. That's good. I should have checked in earlier, but yeah, Hamza. It is kind of like a review day. Now tomorrow we are going to have like a more formal review day. Once I put together like the test breakdown. So you guys almost get 2 review days. So it's actually quite nice before the test. Okay, so here is kind of like the checklist, the step-by-step process that you're going to do whenever you're trying to factor something. Now, again, if you guys have been practicing your factoring, you're already sort of doing all of these steps anyways. The only real new ones that we're kind of adding in here are the step 2 and the step 3. So the difference of squares and the perfect square trinomial questions, okay? So let's just go through a couple. These will be fairly straightforward, but we'll really pay attention to all of these steps, okay? So let's go through the first one here. Now, step 1 is common factors. So for this first example, we have x squared plus x minus 132. There are no common factors, right? So no common factors. Okay, so step 1, we can kind of just skip step 1, right? We don't have to worry about it. Step 2, if the expression has only 2 terms, okay, we can ignore step 2 immediately, right? Because we know that this has 3 terms. It has x squared plus x minus 132. So step 2 is gone, right? That is for binomials. Specifically, this one is for difference of squares. So we definitely do not have a difference of squares. 3, we should check to see if we have a perfect square trinomial. As we saw on Thursday, we have a little bit of a shortcut for perfect square trinomials. So in order to check whether or not we do have a perfect square trinomial, we're looking at the first or the leading coefficient as well as the last coefficient. And we're checking to see whether or not those are perfect squares, okay? So, well, I mean, the first one, 1, that's a perfect square. But 132, I think the square root of 132.
Yeah, it's not perfect.
Definitely not perfect, right? 11.48, blah, 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 blah. So not a perfect square trinomial. So perfect square trinomial. Now, step four and 5 here, those are actually already familiar to us. We've actually already been kind of using those criteria anyways, right? Really, step 4 and step 5 are looking at the leading coefficient and deciding whether or not we want to use sum and product or decomposition. And so in this case, our leading coefficient is 1, which means we can use sum and product. So for we use sum and product. So now when you're actually doing this on a test, you do not have to like do what I'm doing here. You do not have to go like, okay, step 1, okay, can't do step 1. Step 2, can't do step 2. You do not have to like go through the process. Treat this as more of like a mental process, right? This is what you're doing in your head in order to determine what type of factoring you're going to be using at each step, okay? I mean, you can absolutely illustrate your answers like this if that like works with you, but you don't have to. Okay. So let's do sum and product here. So we have switch back. So we have x squared plus x minus 132. So we need to multiply to negative 132, and we need to add to positive 1. Okay, and so, oh man, 132, factors of 132. 12 and 11, I think works.
Yeah.
12 and negative 11, right? Because we have to add up to positive 1. Okay, and then because it's sum and product, we just write our answers down, right? This one's nice and easy. So we have x plus 12 and x minus 11. Oops. And that's it, we're done. Okay. So again, definitely don't show all these stats, like especially when you're doing homework. This is more of like a behind the scenes process. Okay, this is your mental checklist for factoring. Okay. Now, what I will say on a test, the questions will be given kind of like this. Okay, so everything will all just be mixed up together. You won't know what method you're going to use. On the quiz, I broke it up where we had one question with sum and product, one question with decomposition. It will not be like that on the test. You'll probably have like, I don't know, 6, 7, 8 factoring questions, all jumbled up in the same problem. You have to decide what methods you're going to be using. Okay. Okay, let's go on to this next question here. So looking at this, again, cannot common factor, right? There's nothing in common between 16, 88, and 121. Actually, I think 121 is prime. Let's see. From alpha. Factors of 121. Oh no, it's divisible by 11. So definitely not prime, but otherwise, the only thing it is divisible by other than 121 is 11. So actually 11 squared gets us to 121, so that might be a clue. Anyways, these numbers aren't divisible by the same thing, so we cannot common factor. We know we don't have a difference of squares here because we have 3 terms, we don't have 2 terms. But looking at this, this could be a perfect square trinomial, right? Looking at the 16 and the 121, well, I know that 16 is equal to 4 squared. And I know that 121 is equal to 11 squared. Oh, okay. So it seems like this might be a good candidate for using a perfect square trinomial factoring, right? Mm-hmm. And indeed, I can check this middle term as well. And I can say, well, 88, I know that's equal to 2 times 4 times 11, right? Because that's the rule. In order for this to be factorable like a perfect square trinomial, this part has to be true as well, okay? It's not just enough that the first term is a perfect square and the last term is a perfect square. You should check that the middle term satisfies 2 times the first coefficient times the last coefficient. You should still be checking that, okay? So indeed, this does work. And so because this works out really nicely, we can factor this as a perfect square trinomial. I think that was our step 3. So perfect square trinomial. And with this, the way that we set it up, we're only going to have one bracket that's squared. And the first piece is going to come from the first term. So that's going to be 4x in this case. Actually, I have to be a little bit careful. Instead of writing 4 squared, I really should have written 4x squared. So we have 4x, and then we get the other piece from the 11. So 11 heads over there. And then the sign in the middle becomes the sign that we include in our brackets here. So we'll have 4x minus 11 squared. Okay. Now, as you're practicing, of course, I would recommend you checking, right? So if you just type in your result, hopefully this calculates. Okay, it calculates, and if you scroll down, okay, scroll down, you can see under expanded form, it actually just gives us the exact original polynomial. So we know we factored it correctly, okay? So you guys can definitely do this check on definitely as you're going through your homework, okay? All right, let's keep going here. Just a couple more examples. Okay, so looking at this, again, walking through this step by step here. So first step is to factor out all common factors if we can, right? So in this case, we notice that we definitely have some things in common here, right? Mm-hmm. We have 18, actually, yeah, 18. Is that, well, I know I can factor out at least a 2, right? Because they're both even. I know x to the 4 and x squared, I can factor out a x squared there. So yeah, let's factor out a 2 and an x squared. Now, I'm going to be a little bit tricky here, and I'm actually going to factor out a -2. And I won't tell you why, but we'll see why in a second. Okay, so I'm going to factor out a -2 and an x squared. So that's my common factoring step, right? Common factor. And when I do that, so 18 divided by -18 divided by -2, that gets me 9. And then x to the 4 divided by x squared, that gets me x squared. And then 32 divided by -2, that's -16. And then x squared, I take out an x squared. I don't have any x's left. So 9x squared minus 16. Okay. So hopefully you can see why I factored out a negative now. The reason why I did that is the result of like what's going on here inside the brackets is a difference of squares now. Okay. So here I come to, what is that, step 2, I think? Step 2, I can use a difference of squares. Okay. And so the way, again, remember the way that difference of squares works, I'm still going to have the -2x squared. That's just now hanging out front. We won't do anything with that. But then in the brackets here, we're actually going to set up 2 brackets. We're going to have one with a plus sign, one with a minus sign. The first piece here, the 9x squared, I recognize that 9x squared is 3x all squared. I know that the 16 is 4 squared. So indeed, I'm dealing with a difference of squares here. And so the way that I finish this off, I go 3x plus 4 and 3x minus 4. And that's it. Okay. So the cool part about this example is that you realize that sometimes you're not just doing one individual step, right? The first 2 examples, it was kind of just like, okay, we had to use sum and product, right? And that was pretty much it. The second one was a perfect trinomial, and that's it. With this example, though, we use common factoring, and then we did a difference of squares. And so that sometimes you have to use multiple steps through your solution. Does anyone have any questions on that example? Okay, I have one more example to do. Now this one's perhaps a little bit more challenging here. So looking at this, it doesn't really look like anything we factored before, right? There's X's and Y's, and it kind of looks like a mess. Now, our job is to try to figure out a way of making this into a more workable form. So let's see if we can't do that. Now, the one step that we haven't seen before. So, okay, common factoring we've kind of done. Actually, can we common factor anything out here?
Yeah, I think you can take out an x, y.
So I can definitely take out a y, but notice this last term here doesn't have an x in it.
Oh, yeah, okay. Yeah.
So you're right, I can definitely take out a y. So let's actually, we might as well do that first, right? Because that's our step one. So let's take out a y here. So y, and then we're going to be left with x to the power of 5 plus x squared y squared minus x cubed y squared minus y to the power of 4. Okay, not so bad, not so bad. But then beyond that, so this is definitely not a difference of squares, although hold tight on that one. There might be some difference of squares going on here, just in a couple more steps. It's not a perfect square trinomial. It definitely doesn't look like sum and product or decomposition at all. And so this actually brings us to our last step here, which I think we actually haven't seen before. Or I mean, we've seen it a little bit. Factoring by grouping, okay? And the place that we've seen factoring by grouping is when we have to do decomposition, right? So going up to our very first example today, notice here we have, like in this line right here, we have 4 terms, right? We have 8x squared minus 10x plus 4x minus 5. And in order to factor that thing, what we did is we grouped the first 2 terms together, we grouped the last 2 terms together, and then we factored those independently of each other. And so that's a step that you can do whenever you have more than 3 terms, right? More than a trinomial. You can attempt to factor it by grouping. So that's going to be our game plan here. Now, this more than anything, factoring by grouping more than anything, requires you to have seen a lot of factoring before, right? It requires you to have done a lot of practicing before. Just because sometimes the ability to pattern match can be kind of tricky, right? So the more practice you've done, the actual easier it becomes to spot these patterns and apply the formulas you should be applying here. So I look at this and I say, well, how am I going to group this up in order to get like what I want out of this? Now I'm seeing a couple steps ahead, and I notice that if I group these together, so both of them have an x, or I guess both of them have x to the power of 3. I'll be able to actually factor out an x to the power of 3. And when I do that, what I'll be left with is actually a difference of squares. So we'll see that in a moment when I get there. And if I group these last 2 terms together, I notice that they'll both have a y squared in them. So I'll be able to common factor out a y squared. Okay, so I know this seems kind of weird. I'm actually just going to rewrite this, but I'm going to rearrange it. So I'm going to put the 2 green terms together, and I'm going to put the 2 red terms next to each other, just to help us visualize this a bit better. So I have x to the power of 5 minus x to the power of 3 times y squared. Those are my green terms. And then I have plus x squared y squared minus y to the power of 4. And those are my red terms. Okay. So this is what I mean by factoring by grouping, right? You want to collect terms that'll all kind of work nicely with each other. Now, for you guys, like seeing it kind of the first time, or seeing a question like this for the first time, you might look at this and say, oh, I have no idea how to group it, right? Like, how did you decide how to group it? And that's because now I'm looking at like multiple steps beyond this step, right? I'm kind of looking a few steps ahead and using that to inform me what I want to do in my current step. So there is quite a bit of problem solving here, kind of behind the scenes, okay? And so let's go through this now. I look at x to the 5 minus x cubed y squared. I can common factor out an x cubed here. And when I do that, I'm left with, so if I factor out an x cubed, I'm left with x squared minus y squared. Okay, well, that's a difference of squares, right? Because I have something squared minus something else squared. Hamza, yeah, like that's kind of what I'm saying here. Grouping it does require, like, if I grouped it in a different way, it probably wouldn't have worked out quite as well. Remind me in a second, and we'll check that out. We'll see if we can regroup it a different way. So let's go through it this way first, and then we'll see if we can group these up slightly differently. As we'll see, there was definitely some wisdom behind why I grouped these the way that I did. Okay, we'll see that in a second. Okay, so there's the grouping of the first two terms. Now let's group together the second two terms. Here I notice that both of them have a y squared. So let's factor out a y squared. I'll be left with x squared minus y squared. Okay. Now I have something kind of cool here, right? I have an x squared minus y squared and an x squared minus y squared that's common to both of these terms, okay? And it just so happens that both of these are a difference of squares. And so what I can do here is, this is kind of like the very last step of decomposition now, right? I recognize that I have a bracket that's the same in both pieces, and so I can just factor out that bracket. Now, when I do that, I'm going to be left with y, and then I have x squared minus y squared. So that's the bracket that's common, and then everything that's left over, which is x cubed plus y squared. X cubed plus y squared. And now I look at this, and I already recognize that this thing was a difference of squares, so I'm not quite done yet. I can apply the difference of squares formula. So y equals, and then I have x plus y, x minus y. That's the difference of squares piece, right? So that goes to both of these brackets here. And then I have x cubed plus y squared. And this piece, this last bracket here, I can't do anything else with, right? I'm kind of done with that bracket. And at this stage, I'm completely done. That's it, okay? So you can see that these can get kind of challenging, right? You have to be really on your toes about what kind of factoring you're doing at each step. Now, there are a few more example problems. I think in the, yeah, I know number 14 here has it'll have you factor by grouping. Now, really, it's trying to figure out whether x plus y is one of the factors. So, like, for instance, in this question that we did, we saw that x plus y was indeed one of the factors. So for number 14, this would be, the answer would be yes, right? So the idea behind 14 is you want to fully factor it and then see if you see a bracket with an x plus y in it, okay? I think there was one other, at least I thought there was one other common factoring exercise. I think they might be intermixed, right? I can see a factor by grouping exercise in like 6F here. There's another one in 7C. So definitely get some practice with this. It can be kind of tricky. So now let's go back to your question, Hamza. So I looked at this and I kind of grouped it this way. Now, if I grouped it a slightly different way here, so I'm still going to have the y. I'm just going to rewrite out these terms exactly as I saw them. So x squared, y squared, minus x cubed, y squared, minus y to the 4. So let's see if there is another way of factoring this, right? So if let's say I group together, just arbitrarily, let's say I group together the first two terms instead, and I group together the second two terms. And let's see if that's going to change anything, okay? It might not. Let's just see if it does. So actually, I don't think it will, but it'll look different until we get to the end. So if I group together the first two terms here, an x to the 5 plus x squared y squared. So I notice that for those two terms, they both have an x squared in them. So I can factor in an x squared. What I will be left with is, so x to the 5 divided by x squared, that's x to the power of 3. I have x squared, y squared, so I'm taking out the x squared. So I'll have plus y squared. So that's my first factoring step for the first grouping there. Now, if I look at the second grouping, I notice that each of them have a y squared, right? So, and in fact, because they're both negative as well, I'm not just going to factor out a y squared. I'm going to factor out a negative y squared. So I have minus y squared. And then inside the brackets here, I will have so if I take out a y squared out of my first grouping, I'm going to be left with just x cubed, right? Because the y squared is gone. And then if I take out a y squared from the y to the power 4, I'm going to be left with plus y squared. Okay. But now I notice something kind of interesting happens, right? I notice that I have x cubed plus y squared pop up in both of these. It flipped, yeah, exactly. So we're going to get the same result. It's just going to be out of order the way that we saw it initially. So if we go back, initially we had x cubed plus y squared kind of hanging out outside, and then we had x squared minus y squared inside the brackets. Here we have x squared minus y squared outside, and we have x cubed plus y squared inside the bracket. So yeah, it's exactly flipped, but nothing will actually change. So we can just finish this off here. So y equals x squared minus y squared times x cubed plus y squared. And then we just we do difference of squares, same as we did when we did it the first way. So x plus y, x minus y, x cubed plus y squared. And I compare that to what we had down here, and I see that they are exactly the same. Okay. So when I like pick the colors up here, when I pick like, okay, I'm going to group together the x to the 5 minus x to the x cubed y squared, I did that because that's sort of the way that I was visualizing it. That being said, you could have visualized it this way, and you get a completely different answer. The only one that I don't think will work would be if you tried to group together x to the 5, y to the 4. I don't think that would work because then you wouldn't have, would that work? I don't think you'd have anything to like common factor there, right? So I don't think grouping the first term and the last term together would work, but the other groupings do work. Okay, how is that? Does anyone have any questions on that? I would say these big factoring by grouping questions, these are the hardest questions. I mean, I think it's probably a good bet that you're going to have this on the test because I don't know. I think it's a really good like culmination question, right? It's a really good let's see everything that you know, right? I kind of like that. I kind of like that. Okay, that is it for me. So actually, one thing I wanted to point out here, I started to put together your final like summative, or your final ISP exam, what have you. So let's move this out of the way just for a moment here. Now this is not like fully finalized, but I mean, I think the general scope of it is going to be going to be roughly similar to this. So first off, no final exam, which is kind of nice. You will have 3 different tasks to do here, okay? The first 2 tasks are pretty much identical, right? So you have a take-home assessment that deals specifically with quadratics, and then you have a take-home assessment that deals with everything else. So the first unit that we saw, so linear systems, geometry, actually, linear systems, linear systems, the analytic geometry, and the trigonometry. We haven't done trig yet. Yeah, this is, Hamza, this is for like, I'm going to try to give this to you by the end of the week, if not sooner. And then it'll be due towards the end of the year. Okay. So essentially, for each of these take-home assessments, you're going to be given 8 problems. Think like test level problems. So nothing like crazy difficult, but not too easy either. So for the first one, you'll have, it's all going to be on quadratic. So you'll have like 2 for properties, 2 for factoring. And then the chapters that we're going to be doing next, we're going to have graphing questions and quadratic equation questions. We're going to submit these towards the middle, end of June. And then on the last 2 days, let me go back to the schedule here. On the last 2 days, we're not going to have classes necessarily, but what you're going to do is you're going to schedule like a time slot with me, and then you're going to walk me through 1 or 2 of the problems. Okay, so kind of exactly like we're doing in the problem conferencing. Okay, so it is not just enough for you guys to have like a nice like solution put together. You have to be able to support your solution. Okay. Or if I ask you kind of like a peripheral sort of related question, hopefully you have enough knowledge or background info to kind of answer that, okay? So each of these take-home assessments, they're kind of 2 pieces, right? There's sort of like the assignment or the test piece, and then there's the problem conferencing piece where I then kind of orally quiz you on what you wrote down, okay? Any questions about these first 2 assessments here?
Nope.
Okay, cool. The third one is a little bit different. I think this could be really, really cool. I know obviously like during this like virtual learning business, it's kind of a challenge to have a lot of like feedback and stuff like that. And I can't say for sure, but I'm sure some of you are doing a lot of like self-studying and self-learning, which is fine, right? Like I'm there to help, but obviously, especially in this circumstance, you have to take a lot of the responsibility upon yourself. Or if you don't, then things probably don't go so well. So essentially, I had the idea. I put down a couple of really cool like YouTube mathematic channels, right? So I'm sure you've all heard of Khan Academy. His videos are obviously fantastic. He does it kind of like I do it, right? Like he has his tablet set up and he doodles on it and draws diagrams and all that. His videos were the videos that I used when I kind of was in your guys' situation. I added a couple more. So 3 blue, 1 brown is really good too. He uses a lot of like computer animations. And then there's others that just have like a piece of paper with their camera directed down at them. So some of these YouTube channels that post like mathematics problems and mathematics lessons, they're really, really low tech, which is kind of cool, right? Meaning like everyone can kind of put together one of these sort of scenarios. So I like a few examples of each. Now for this third part, what I'm going to want you to do from the first 2 assessments, so from the take-home part 1 and take-home part 2 assessments, I'm going to want you to pick one of the problems to create a video kind of outlining your solution. Okay. It doesn't have to be a long video. You guys have seen like the videos that I put together for some of your homework problems. They can be like 5-ish minutes, so it doesn't have to be anything significant. You can kind of use or adopt whatever style you'd like. So if you want to do like, if you have like a tablet handy and you want to like doodle on the tablet and just narrate, that's totally fine. If you want to pull out a piece of paper, so here, let's see this one. Where will it end up here? Oh, over here. So like his videos, it just has like he's literally just doodling on a sheet of paper, right? So you can make this as high tech or as low tech as you want. But essentially your job is to create a video explaining your solution to one of these problems, okay? And then maybe towards the end of the term, we'll just like pull them all together into the Google Classroom, and then you guys can use it as sort of a final review. But we'll see about that part. Now this isn't set in stone. One other thing that I kind of want to incorporate is for you guys to post like additional, like a couple extra questions for the class to do as well. And then that'll be part of this third part as well. Okay, so just a couple really quick additional problems that are really similar to the problem that you explained with your video. Okay. Any questions on that? Okay, cool. This is kind of my workaround to do like presentations, but virtually. So for those of you that like don't like getting in front of the class, then that's fine, because we're not like in front of a class here. It's all pre-recorded, so you can take your time kind of putting it all together, making sure you have like a good script put together. But yeah, I'll pull this all together into like a nicer document. This is just sort of my rough draft. I was just trying to get the dates all set up and whatnot here. So I'll pull this all together. I'll post some rubrics and everything, so everyone's really aware of what's going on. And I'll try to get the actual questions posted towards the end of this week, because a lot of this you can already start doing right away, right? Like there will be a substitution and elimination problem. There will be an analytic geometry problem. There will be a factoring problem. So a lot of these you can do along the way. So this is not meant to be like a final week crunch. You can just chip away at problems as you go. And that way there shouldn't be any burden towards the end of the year. Okay?
Yeah.
Cool. Do you guys know what, a lot of you are in history as well, right?
Mm-hmm.
Do you guys know if you have like a final history task?
No, we haven't talked about it yet.
Haven't talked about it yet?
What it is.
Okay.
We will have one though, obviously, but
Yeah, definitely. My real worry was that you would have like an essay, like a big essay or something to do. So I just wanted to make, just because like history, it has a lot of essays, right?
no, I was just about to say, I said, why do I feel like we're actually probably gonna have an essay?
We're definitely gonna have an essay. I'm gonna call it right now. We're gonna have an essay.
I don't know. It's just something. It's something that I feel is gonna happen for sure.
I would assume so. So I didn't want to make it like too much right at the end of the year, because if you have like an essay and then like a full exam to study for, I think that would be too much. So this is my way of like making it an exam, but not really like a stressful exam, right? You'll be able to start this exam as soon as I give you the questions. So really, if you do like one problem per day from now until like early June, you're going to be fine. Okay. Okay. So I might actually post this like rough document just so you guys can kind of see it and just so you guys are aware. But all of this is kind of subject to change a little bit. I'll try to post the problem sets towards the end of the week so you guys can get started on that. Okay. Beyond that, that is it for me. So let's take a break. Please do go through these homework problems. Okay, I'm going to start being a little bit more strict on homework. Again, going back to what I talked about at the beginning, you treat homework seriously. I know it doesn't seem like much, but especially in math, doing homework is probably really the most important thing you can do in order to learn the material, right? I could do examples for days straight and it won't help you as much as actually doing the homework, okay? So take a break and then get to homework. And then stay tuned for the Google Classroom. I'll post a test breakdown later today, okay?
Okay.
All right, bye guys.
Bye.